My name is Sarah Meyer, and I'm a seismic field tech for the Alaska Earthquake Center. And right now we're at the testing facility for the Alaska Earthquake Center. It's part of CIGO, which is the College International Geophysical Observatory. So there's a bunch of different projects that are happening here to test different equipment for UAF. So ours in particular is the Seismic Vault, and this is where we're testing our seismometers and our accelerometers and also our digitizers on the rack behind me before and after we put them in the field. So behind me you'll see that there's this concrete pier, and it's basically this giant piece of concrete that is mated to the bedrock underneath it, and it gives us a really clear signal of earthquakes happening in the area, as well as what's called teleseisms, which are really large earthquakes happening around the world. So when we have our sensors set up here, we're looking for both local earthquakes and teleseisms, and we look for making sure that the sensors are performing properly and that the cables attaching them are also performing properly. And to do that, we also have these digitizers on the rack here, which basically translate voltages in the sensors into waveforms for us, and that's what gets sent back to the lab. We test instruments before and after going into the field, and also brand new, just to make sure that the sensors are performing to our specifications. We have all sorts of things happen to our equipment in the field. We have bears pulling them out of our vaults and using them as volleyballs, and then we have some of our vaults get flooded with water, so we want to make sure that the sensors are still performing how they should be. So when we go out to a site and we pull the equipment out, we'll bring it back here and we'll set it on the concrete pier for a couple weeks, and then we'll look at all sorts of different behavior on the sensor to make sure that it's still good. So the digitizers are used to translate the waveforms for us, and they also give us some diagnostic channels that we can use remotely. So they're recording things such as temperature, voltage, things that we can look at remotely and diagnose whether the site is performing how it should be. A lot of our sites utilize batteries throughout the winter to make sure that they can make it through the snowy season. And so our digitizers actually show us what voltage the site is at, and we can monitor and make sure that the site is staying at a healthy voltage throughout the winter. And if it looks like it's getting too low, then the next time we go out there, we put more batteries or more solar panels out there. So these digitizers are really helpful for more than just translating voltages into waveforms for us, even though that's their primary reason that we use them, but they also are kind of like our very own diagnostic box, essentially.